Today we're going to move on to Unit 4, Lesson 23. We're going to deal with polygons on the coordinate plane. So we're still going to be finding area, only now we're going to be using these figures on the coordinate plane. So, use what you know. You've learned about plane figures such as rectangles and triangles. In this lesson you will learn how to use coordinates to analyze plane figures. Take a look at this problem. Okay, it says Cheryl walks her dogs after school. The routes she takes are shown on the coordinate grid to the right. Route 1 starts at point A and continues to point B, C, D, and back to A. Route 2 starts at P and goes to Q, R, S, and back to P. Which route is longer? So, we're going to use what we know to solve this problem. It says which pairs of points on Route 1 have the same x coordinates. Now remember, the x coordinate is the first number in the ordered pair. So when we look to see which numbers have, or which points have the same first number, we see that A and D both have 2 as the x coordinate, and we see that B and C both have 8 as the first number in their ordered pair. And then it wants to know which ones have the same y coordinates. The y coordinates is the second number. So if we look at the y coordinates, A and B have the same, it's 6. And D and C have the same, which is 2. So B says the way to find the distance between 2 points is that have the same x coordinate or the same y coordinate is by counting the units between them. So if we look at Route 1, to find the distance from A to B, we would count. So when we count from A to B, we find that we have 6. From B to C would be 4. From C to D is 6. And from D to A is 4. So if we then want to add those up to find our total distance, we would get a total of 20. Looking at Route 2, we find the distance from P to Q, and we count and find 3. From Q to R, we would find 7. From R to S is 3, and from S to P is 7. So if we add all of those up, the total distance is 20 on this one as well. So D says, explain how you can find which of the 2 routes is longer. Well, we would have to compare the lengths of both routes. When we do that, we have 20 and 20, so we can say they are the same. So let's go and find out a little more. It says each of Cheryl's routes on the previous page form a rectangle on a coordinate plane. A rectangle is one type of polygon. A polygon is a closed plane figure whose sides are line segments that intersect only at their endpoints. On the coordinate plane, if a side of a polygon is on a horizontal line, then its endpoints have the same y coordinate. If a side of a polygon is on a vertical line, its endpoints have the same x coordinate. One way to find the length of a horizontal or vertical line segment is by counting. The length of a segment is always a positive number because it's a length. It is often helpful to place a vertex or a side of the polygon on one of the axes of the coordinate plane as shown on the diagram below. So you can see that in this first one here, the points are all on an axis. Over here on this one, you can see that the 2 lines that form the outside of your triangle are on the axes. So number 1 says, explain how you could find the distance between points 3, 6, and 7, 6 on the coordinate plane. There are actually 2 ways to do this. One way would be to plot the points and then count the spaces from point to point. Oops, that's an M. Okay, the other way would be to use the coordinates themselves. Okay, so I'm going to go up here with this. We can say they have the same y coordinate. The second number is the same. So since they have the same y coordinate, we can find the absolute value of the difference. Of the x coordinate. So, for example, if we have 6 is our same number, so we take our 3 and our 7 and we subtract them and find the absolute value of that. Okay, so it would be the same thing as switching those around. We would do 7 minus 3. The absolute value of 7 minus 3 would be 4. Okay, same if we took 3 minus 7, the absolute value would be 4. So the distance between the 2 points would be 4. So the next problem says, an athletic director is planning to refinish the floor of a rectangular athletic court. 3 corners of the court have the coordinates -4, 2, -4, -3, and 8, 2. Find the coordinates of the 4th corner and the perimeter of the court. So one way we can do this is by graphing it. You can graph the information that is given and then sketch the rectangle. So draw a horizontal line that goes through point -4, 3 and a vertical line that goes through point 8, 2. The point where they intersect is going to be the 4th corner of the court. So then to find the perimeter of the court, we have to find its length and width. The length is the distance from -4 to 2, -4, 2 to 8, 2. The width is the distance from -4, 2 to -4, -3. Or you can count up your squares. We can model it, and we can use words to describe the locations and the 4th corner of the court. So it says the 4th corner of the rectangle is a vertical line that goes through 8, 2, so its x-coordinate is 8. The 4th corner of the rectangle in a horizontal line that goes through -4, -3, so its y-coordinate is -3. So then you could say that our point is 8, -3. So let's go through and answer a couple questions about this. Number 2, what are the coordinates of the 4th corner of the rectangle? Explain how you found it. Well, based off that previous page, we know that the coordinate would be 8, -3. And you could say I counted down from 8, 2. And over from -4, -3 until they met. Number 3, explain how to find the distance between -4, 2 and 8, 2 using absolute value. The y-coordinate's the same. So you find the absolute value of the x-coordinates. So that would be the absolute value of -4 minus 8, which gives you 12. Number 4, explain how to count to find the distance between -4, 2 and -4, -3. So the x-coordinates are the same. So you count the units between the y-coordinates. And it's 5 units. So number 5 then says, describe how to find the perimeter of the athletic court. Well, we can either count or use absolute value. To find the lengths of each side, then add them together. So in the case of this court, we would be adding 12 plus 12 plus 5 plus 5, which gives us a total of 34 units. And it's just perimeter, so there's no squared or anything attached to it. It's just units. And then number 6 says, explain why it is useful to know how to find the distances on the coordinate plane, both by counting and by using absolute value. Well, counting is useful when it's close. The points are close. Whoa, back up. Sorry about that. Points are close. Count. Points are far apart. Absolute value. That way you don't have to count as much when they're a long ways away. So, now let's take a minute and go through the try it. I want you to use what we talked about above and go ahead and complete 7 and 8. So pause the video, work your way through these. You can draw just a small little coordinate down in the corner. And when you're done, then you can resume the video to check your answers. Okay, number 7 says the coordinates of 3 corners of a square are -2, 0, 1, 0, and 1, -3. Graph these 3 points. I've done that down at the bottom. Not perfect, but it looks all right. What are the coordinates of the 4th corner of the square? And then draw the square. So basically you're just going to draw your lines out, or we can count. So if I count, I can see I have 1, 2, 3 from here to here, which means that I would go 1, 2, 3, and my point would have to go here. And then I need to make sure that I have 1, 2, 3 here, and 1, 2, 3 there. So here would be my square. And like I said, not perfectly drawn, so it's not exact, but close enough. So it says, what are the coordinates of the 4th corner of the square? Well, we would be at -2, -3. Number 8, what is the perimeter of the square in problem 7? Well, since it's a square, and we've already counted them up, each side was 3. So I'm going to take 3 plus 3 plus 3 plus 3. When I get that total, it would be 12 units. Okay, so the next question says, on a map of a county park, the park entrance is located at 0, 0. A community garden is located at 4, 3, and a playground is located at 8, 0. What shape is formed by a path connecting the 3 locations? The park director's planning to grow grass inside the shape formed by the path. What is the area of the shape? Well, we can make a graph showing the given information. So you can see they've plotted the 3 points, 0, 0, 4, 3, and 8, 0. The park entrance is labeled E, the community garden is G, and the playground is P. The polygon is a triangle. So then we can count our spaces, count our boxes to find our height and our base so that we can find our area. So when they did that, you can see that they have 8 units for the base and 3 units for the height. Okay, so then we can solve it using our formula. Area equals 1/2 times the base times the height. So we keep our 1/2. We know the base of our triangle is 8. We know the height of our triangle is 3. So then we can work our way through it. They went ahead and did 8 times 3, which is 24, and then half of 24 is 12. So the area of the triangle is 12 square units. So let's go through and answer these questions now. Explain how you know that the base of the triangle is 8 units long. Well, we can look and see and say that we counted the units between the points. Explain how you know that the height of the triangle is 3 units. Once again, we counted the units. From the base to the point. Because remember, your height of a triangle is from your base perpendicular to the point. So, number 11 says, Christina divided triangle EGP into 2 smaller triangles by drawing a vertical line from G to the axis as shown. What do you notice about EGQ and PGQ? So if we look at those 2 triangles that she split right here, what do we notice? Well, they are the same size and both triangles. So number 12 says, how could you use Christina's method to find the area of EGP? We find the area of one of her triangles then multiply by 2. Because they're the same shape and size, so we find the area of 1 and then multiply by 2. So if we were to do that, it would be 1/2. The base is 4, the height is 3. So when we multiply that out, that would be 6, and then we multiply it by 2 to find out that it's 12. So 13 says, suppose the coordinates of point G were 4, -3 instead of 4, 3. Would the area of the EGP triangle be the same? Explain why or why not. Well, if right now the point is a +3 and we take and move the point to a -3, we're still the same distance from our axis. So yes, the area would be the same. Because the triangle is just flipped. Is just flipped. So now take another minute and do the try-its. Use what we just talked about to solve the problems. So you're using the situation a baseball diamond is in the shape of a square with bases at 0, 4, 4, 0, 0, -4, and -4, 0. The pitcher's mound is located at 0, 0. So you're going to find the area of the part of the square that is in quadrant 1, and then what is the total area of the square. Pause the video, take a couple minutes, work them out. When you're done, resume the video to check your answers. Okay, so you can see here that I've taken the 4 points that are listed and I've went ahead and drew out a rough sketch of the field. And then it says the pitcher's mound is located at 0, 0 in the middle. So it wants to know what is the area of the part of the square that is in quadrant 1. Quadrant 1 is located over here. So I have to find the area of this quadrant right here. So this triangle. So my base would be 1, 2, 3, 4. My height would be 1, 2, 3, 4. So I would do 1/2 times my base times my height. Half of 4 is 2. 2 times 4 is 8. So it would be 8 units squared. So then number 15 says, what is the total area of the square? 2 ways I can do this. I can find the base and height, or all 4 of these should technically be the same shape and size. So if that was the case, I would take my 8 square units and multiply it by 4. 8 times 4 would then be 32 units squared. So if you have any questions, make sure you raise your hand and I can ask, or you can come ask me. Then you need to get back onto Classroom and you need to complete the exit ticket. Once you finish the exit ticket, I need you to go ahead and turn the page and work on 236 and 237, and then do the independent practice pages 238 and 239. If you have questions, raise your hand and I complete what you need to do.